Hey everybody, this is Larry. This is day 16 of the January Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem when my computer wants to load it. Or maybe Leetcode. Leetcode was having some issues with login for me. But in any case. But before that, since it is taking a while for this to load anyway, I just want to talk about, I don't really promote that many things in general. And I don't, and this is at least topical. But yeah, I was gonna say our boy Josh, though he's getting older. I always forget that, time flies. But yeah, Josh and apparently Andrew Tam on dmoj.ca. You could probably Google this actually. But in any case, yeah, they have the contest running. It runs for another Monday 20th, so I don't know. Whatever that time is. I guess actually it tells you. In 5 days and an hour from right now when I'm recording, so maybe a little bit less by the time you get here. In any case, yeah, people ask me if I do competitive programming, and the answer is no for the most part. This is actually one of the few things that I do, aside from maybe if you do Leetcode, we want to consider that. The reason is because Josh write very good quality problems. I'm always a fan, and I'm always learning from the problems in general. So yeah, so definitely, the only thing I would, so definitely check that out if you have time. It's a 3-hour window. You have 6 problems, and even though it is 6 problems, I don't know if this is a tip. I think this is in general. It is a different format, so so it is different from say Codeforce or something. One is that you don't get penalized for wrong answers, but you have a cap of 50 submissions, so definitely use them as much as you can. And second is that each problem, for the most part, I think, have a subtask, if you will, so that to get partial credit. So definitely do that. So if you can solve the harder version of it, see what you can with the easier version. Anyway. Yeah, definitely check that out. I just want to promote it, put the word out there. There's still another 5 days, so that means at least part of the weekend. So definitely, yeah, that's it. I don't get paid for it. It's not sponsorship or anything, And those of you know, I'm a fan of Josh, so I want to support him. These things, but also it's just good quality problems in general in the past, and yeah. Anyway, let's take a look at today's problem. Yeah. We have 2425 bitwise XOR of all pairings. Okay, so what does that mean? I don't know. You're given 2 0-indexed array, nums1, nums2, consists of non-negative integer. There exists another array, nums3, which contains the bitwise XOR of all pairing of integers between nums1 and nums2. Every integer in nums1 is paired with every integer. What? Return the bitwise XOR of all integers in nums3. Okay, I think I just read a lot of stuff and I don't know what's going on, but okay. nums3, which contains the bitwise XOR of all parents of numbers of integers between x. Okay. So I mean, of course, the naive thing is that you could do n times m, right? Let's take a look at the constraints, and of course, that would be an easy problem. Given that n and m is going to be 10 to the 5th, we have to do a little bit smarter. I think the idea here then is just thinking about just the pattern, right? So we want to bitwise all the numbers in nums3. So okay, so let's just play around with some ideas, and maybe I'll just call them A and B just because it's easier to write. So let's say maybe we have A, maybe we have, I don't know, let's just start with 2 numbers, right? And play around with that. And then what does that mean? So that means that we have A0, right? Oops. Right? Something like that. And then A1, B. So these are just the combinations. So hopefully straightforward so far. And then now we're trying to XOR all these numbers, right? So what does this gives us? This gives us, well, you could write it out, right? So you have XOR B0, XOR A0, maybe I should just do a copy and paste and it'll be slightly faster. Yeah, I don't know. So my computer's a little bit slow, but my typing is a little bit slow as well. Anyway, so you have this, and then when you take a look, and then you just go, okay, well, XOR operators are what is that word where you can do like I don't know. I forget the. Some days I just don't have, you know, I record these things live, so some days I just don't remember. But the point is that you can rewrite this, right, in that like a plus b plus c is equal to a plus c plus b or something like this, right? So anyway, then you can rewrite this as x and then b0. Maybe I'll just rewrite one of them at a time, right? But you can see immediately though. I mean, I just kind of swapped these two, right? And you can see immediately that we have a sub zeros in the front and they cancel out, right? And then similarly, you can see that this b0 will cancel this out, b1 will cancel b1 out, a1 will cancel a1, and then we effectively, yeah, this is going to be 0. So this is going to also, like, another thing to notice is that this is irrespective of the input, right? As long as a has 2 numbers and b has 2 numbers, it doesn't matter what the numbers are. It would all cancel out, so it doesn't matter. Okay, but well, that's not sufficient, of course, both because you look at example 1 and it has a possible answer, and also just in general, you know, you have to do more data points than that. So then, yeah, and then maybe we'll try something like, you know, 3 items, right? I mean, I guess 1 item is very obvious in that then it's just a0, right? And then what happens with 3 items? And that's how I'm trying to like see if I could sense some patterns, right? So with 3, I am going to just copy and paste this a little bit so that it's slightly less typing for me, right? And there's still only 9 cases, 3 times 3. So it is, you know, tractable, right? And then now you know, all we have to do, and this is XOR of all these things. I'm not going to write it out like I did earlier. You can just kind of see that, well, this cancels out this one. You have odd number of a naught or a sub 0, odd number of this, a1, odd number of a2, and then also odd number of all the b side, right? So that means that, well, what does that mean? That means that, well, if you have odd number of them, all the even cancels out, so you have 1 number each. And well, there you go. So then now it just becomes dot. So I guess it's actually only 6 numbers, so maybe I should write them out. And that would be your answer. Okay, so those are 2 cases where odd and odd, right? And then now there's really only 1 more case, which is without loss of generality, because I think it's easy to kind of see how this extends, right? Because if a is equal to 5 instead now, what does that mean? Well, that means that you add 2 more a sub zeros here. So as a result, the 2 a sub 0, a sub 0 and b3 and b4. So a sub 0 would cancel out, a sub 1 would cancel out, and yeah, and so forth. And then for each number in b, it shows up 5 times, so they all get cancelled out as well, except for 1 number. So yeah, and I think that's really the idea here is, yeah, I mean, you can, without loss of generality, play around with something like this as well, which is even odd, and really this is the last possibility, and okay, fine, let's just do it then, right? So if we have something like this, and you could kind of generalize it everywhere, but I'm being very exhaustive right now, but you don't even have to do this. But yeah, so then you have just these 2, right? And of course, then now you can say, well, a sub 0 is odd, the odd number of them, so they don't cancel out, or all of them cancel except for 1, and a sub 1, all of them cancel out. So there you go, right? That gives you all the answer you need if you want to generalize some of this. But actually, there's another way, right? The reason why I kind of want to write this out today is that I think there are very often, I mean, maybe this one is a little bit like, if you're able to see it early and if you're able to see it quick and you have the intuition, that's fine, right? But there are problems that kind of have the same feel, but you just don't know where it turns out. And in that case, it is, you know, you can just play around small numbers, either manually, as you see I do, as you see me doing it here. But the thing that you can also do, right, is is write a brute force program that allows you to kind of see these things as well sometimes, right? So that's really the ideas. But of course, there really is a simpler problem to this, honestly. I just want to give you some ideas. Let's say the number of A's, they're N, and number of B's, they're M, right? Well, what does that mean? That means that in the final, like if you kind of draw the grid out like we did, that means that for each A, for each A, there are M versions of them. I don't know if that version is the right word, but they're just M copies of them, right? Copies is probably better, right? And then for each B, there are N copies of them. So then the question is, do they cancel out, right? And that's it. If it's even, so that means that for, you know, you just throw it in. If M is even, then all the A's cancel out. If M is odd, only one remains. Everything else cancels out, and so forth. And that's the final answer, right? So then maybe you could have something like I don't know, XOR array, and you could, if you're slick, you can probably write this in a one-liner with a reduce function. But I'm lazy, so you know. Yeah. So then here maybe you have like x is equal to 0, and then for for a in array, and then we return x, right? And then yeah, that's it. And then maybe you have an answer is equal to 0 if length of num sub 2 mod 2 is equal to 1. Then we XOR it with the XOR array of nums 1, and then same with the other number, right? Or the other array with. And that's it. If I typed it correctly, that's basically the idea behind this one. Yeah, I think the thing is that if you watched it all the way up here, well, let me know in the comments real quick. But as you can see, though, like, yeah, does it take a long time to write all those things out? Yes, right. It feels very long anyway, even though actually it's only been like 10 minutes into this problem. But you know, it definitely feels very long, and maybe wrong, but long, right? But look, if the alternative is that you're not understanding the problem, you cannot get an idea, you know, it lets you play around with the problems. And that's what sometimes I mean by playing around the problems and making these observations. This one, you can kind of see it as you kind of spit it out. And yeah, what is the complexity of this, right? Well, this is linear, right? So can't really get beyond that in some cases. So that is going to be your lower bound. That's all I have with this one. My eyes are so tired, I can't keep it open anymore. I don't know. I ran a couple of miles today, but I don't know. It's just what it is. But yeah, thanks for watching, though, everybody. Yeah, go on DMOJ. I think you could probably Google for DMOJ and YAC, and you could go play around. But that is all I have for this one. Let me know what you think. Thanks for watching. Stay good. Stay healthy. Do good mental health. I'll see y'all later and take care. Bye bye.